Okay, we're going over the geometry EOC released items, and we're going to practice the problems using our reference sheet and any other helpful tools like our calculator. This says two statements about triangle JKL are shown. Measure of angle L is 90 and the sine of angle J is 99 over 101. So I don't have a picture for JKL. I'm going to draw a picture. I know there's a 90-degree angle, so I'm going to put a 90-degree angle box here, and this is angle L. My other angles in my triangle are J and K. The information says we know the sine of angle J. So if we look at our reference sheet, we know that sine is opposite over hypotenuse. So opposite over hypotenuse. In our triangle, hypotenuse is always the longest side, which is across from the right angle. So this is 101. Opposite from J would be down here, which is 99. We need to figure out the cosine of K. So when we look at our reference sheet, cosine of K is adjacent over hypotenuse. So I know for sure 101 goes in the bottom because that's the hypotenuse. Adjacent to K, we need to know what that word adjacent means. Adjacent leg is the leg that touches or is next to angle K, so it's 99. So I did not have to figure out my missing side of this triangle in order to solve this problem. This is going to be B. Okay, in some situations, you may have to solve for the third side of your triangle before you can answer a question like this. You would have to do Pythagorean theorem to get that missing side and then answer the question. It just depends on what they're asking you. Okay. For number 2, we have line segment MN, and it has these endpoints. Point P is on line segment MN such that the ratio of MP to PN is 2 to 1. So just thinking about what we have here, we have MN and P is somewhere in the middle. The ratio is 2 to 1. Right? We know this information. We only want to know what the x coordinate is of point P. So it's going to help to draw a picture to see what's going on. Remember when you have your EOC, you get this work folder, right? And on the back of the work folder is graph paper. It's going to help to draw a picture of this so you can see what's happening with this problem. We have the point M at -710. And N at -1,1. Point P is somewhere on here in the ratio of 2 to 1. We're only concerned about the x coordinates. So that means I'm concerned about how far I'm moving horizontally. If I make my little triangle here to do my rise and my run, I'm only concerned about my run because that's where my x is. If I count how many spaces this is, it's 6 spaces. Okay, my ratio here is 2 to 1. That means I have 3 parts that I'm trying to split this line into. Okay, if I'm trying to split that run into 3 parts, each part is 2 units long. So this is how I would split it up. To get my ratio of 2 to 1, on the left side I want 2 parts, on the right side I want 1 part. So I want 2 parts, that's going to give me 4 units here. So I know I'm moving 4 units this way. So if I'm moving 4 units this way, I'm going to be right here for point P. So my x value for point P is at -3. Right, our next problem says, which statement is true when a 3-dimensional figure is dilated by a given scale factor? So when we have a dilation, we know that we are either increasing, which is an enlargement, or decreasing, which is a reduction. We have some different situations here. When our scale factor or our K value is greater than 1, we know that that means our figure is getting larger. And when our scale factor is between 0 and 1, we know that that means it's getting smaller, so we're reducing it. So a dilation by a scale factor of 2/3 results in an increase in volume would be incorrect because 2/3 would give me a reduction. A dilation by a scale factor of 0.1 results in no change. That's wrong because it would be a reduction. A dilation in scale factor by 3/2 results in a decrease. We need to know that 3/2 is the same thing as 1.5. And if you're not sure about that, remember you can always use your handheld calculator to check to see what that fraction is. So if I put that fraction in my calculator and I'm not sure what that is as a decimal, I can use my fraction to decimal key, which is hit the green button and then the arrow, and it gives me 1.5. Okay. So 1.5 should be an enlargement because that's bigger than 1, so it's not a decrease. And then a dilation by a scale factor of 3.5 is an increase. So D is our correct choice here. All right, then number 4, we've got two parallel lines. F and G are cut by our transversal H. Remember, transversal is the line that cuts through the two parallel lines. What are the values of X and Y? So we need to remember some of our relationships to do these problems. Okay, I see that this angle has both X and Y, and this angle only has X. So this is the one I'm going to focus on first. We need to remember that we have interior angles here, and when we have interior angles that are on the same side of the transversal, those angles are called consecutive interior. Our consecutive interior angles are supplementary. Okay, these angles are supplementary. That word supplementary, remember, means equals 180. So these angles that are on the same side of the transversal and on the inside have to add up to 180. So I would just subtract the 94 from the 180 to get that my X, my missing angle here, is 86. Okay, so now I can rewrite this expression as 86 plus Y because I know what X is. Now I can approach this problem two different ways. I can think about these linear pairs that are right here because these two angles make a straight line together. So I know if this is 86, this angle has to be 94 because they have to make 180 together because these make a line, right? The other way I could think about it is 94 and this angle are alternate interiors, and alternate interiors are congruent. So that's why I would know that they're both 94. Okay, so either way, I know that that angle is 94. So 94 is equal to 86 plus Y, and then I would just have to subtract the 86 to get that my Y is 8. So I have two parts to answer for this question. My value for X is 86, and then Y is actually on my next page. Y is going to be 8. Okay, and these are ones where we would just type the answer in. All right. For the next one, we have a properties question. It says, which statement must be true for all parallelograms? So I want to think about parallelograms. Sometimes it might help to just sketch a picture of a parallelogram so you can think about what the properties are saying. The first one says diagonals are congruent. So if I think about what diagonals look like, these are diagonals. I can tell that this one is definitely shorter than this one, so this is not true. Diagonals are perpendicular. Well, perpendicular means that I have a right angle. So it would be right angles here. I can tell just by looking at this that these are not right angles. If I wasn't sure, I could draw like another parallelogram that's maybe stretched out more, and then you can really tell that those are not perpendicular. So not A, not B. Opposite angles are complementary. Complementary means 90 degrees. Opposite would be these angles right here. I can tell these angles are obtuse. There is no way two obtuse angles are going to make 90 degrees. So this one does not work. Consecutive angles are supplementary. Supplementary means 180. Consecutive means they're next to. So this would be like talking about this angle here and this angle here. Those angles are next to each other. That is a true property, that consecutive angles are supplementary. Okay, it could also be this angle and this angle, or this angle and this angle. They're the ones next to each other. Okay, so that is a true property. Drawing a picture like this might help you reason out your choices. Okay, we're going to stop the video here and then start the next video with number 6.